One animal can survive being crushed by 39,000 times its body weight. Others build armor from bone or even the same material as your fingernails. Some may even be helping scientists engineer self-repairing materials. So how did evolution design something this strong? The ironclad beetle plays dead, despite having one of the strongest exoskeletons in the biological world. The ironclad beetle's elytra, which is its wing covers, is made up of protein-rich chitin, allowing it to be much stronger than other beetles with less protein. In the case of the ironclad beetle, its elytra is fused together in a micro-jigsaw-like pattern. Because of that, the ironclad beetle cannot fly. The shell of the ironclad beetle has multiple layers of protein-rich chitin, contributing to its hardness and resistance to bending under pressure. Near the front of the beetle, around its vital organs, the ridges are highly connected, which are stiffer and more resistant to pressure. Near the back of the beetle, the ridges are not as intricately interlocked, which allow the bottom halves of its exoskeleton to slide past each other just slightly. That slight flexibility helps the beetle absorb compression in its body, making them harder to crush. Ironclad beetle shells are so strong that they can withstand forces up to 39,000 times its body weight. That is like a 200-pound human enduring 7.8 million pounds of force. Surviving 39,000 times your body weight is crazy, but armor does not stop at exoskeletons. Some mammals evolved their own reinforced design. Armadillos are small mammals related to sloths and anteaters. They are the only mammal to have a shell, and it is not just for show. Their carapace is a multi-layered structure made up of bone and keratin, allowing it to be both incredibly strong and flexible. The shell's primary protective layer consists of hexagonal or triangular plates of bone known as osteoderms that grow within the skin of the armadillo. The plates are all individual pieces connected with collagen fibers that act as shock absorbers and help to disperse energy across the shell instead of cracking at a specific point. Only the three-banded armadillo rolls into a ball. The strength and design of the carapace causes bites to deflect, making it incredibly difficult for an animal to get a proper bite. The armadillo reinforces keratin with bone, but pangolins prove keratin alone can be just as powerful. Pangolins are small nocturnal animals found in Asia and Africa. They have evolved in a similar way to the armadillo, but this similarity is an example of convergent evolution. Pangolins do not have a hardened shell, rather they have hardened scales. Their scales overlap and are made of keratin. They are flexible and are arranged in a three-layered structure of perpendicular keratin cells. The lamellae is interlocked with nanoscale stitching that helps to increase the structure's shear resistance. The mechanical properties of the scales change based on moisture. Wet scales have higher plasticity, flexibility, and toughness. Pangolins will roll in wet mud, which help the scales repair and withstand pressure better, as well as help with their thermal regulation. Whereas dry scales are more rigid with maximum hardness, perfect for acting like a defensive shield and protecting them from their environment. Scientists are studying pangolin armor to engineer materials that protect both the wearer and themselves, potentially even self-healing. Pangolins use armor to survive predators. Crocodilians are the predators, and they're armor too. Alligators and crocodiles are apex predators. Not many animals will challenge them, but in case they do, alligator and crocodile skin acts as an incredibly tough armor, protecting them from predators or potential battles with rivals. Their skin has bony plates called osteoderms or scutes that are dense and full of calcium that grow within the skin, covered by keratin plates mainly on their back. They are layered in an interlocking structure that does not overlap and allows for maximum flexibility. Their skin acts as armor, helps regulate heat, and even influences blood chemistry. The scales absorb heat, warms their blood, then transfers it throughout their bodies, as well as transfers ions into their bloodstream to stop lactic acid buildup when they hold their breath underwater. Crocodiles tend to have more of the armor plating than alligators, making them much tougher but less flexible. They are capable of withstanding crocodilian bites, jaguars, and in rare cases, even small rounds. Crocodiles have their armor within their skin. Turtles take it further by fusing it directly into their skeleton. A turtle shell is part of its skeletal structure and protects its internal organs. The shell cannot be removed and grows with them. It is composed of two parts fused together. The top is called the carapace and the bottom is the plastron. Turtle shells are made up of around 50 bones, which include its spine and rib cage. The bony shell is covered in scutes made of keratin, which help to further protect the shell and harden it. Some species have the ability to retract their limbs and head into the shell when in danger, making it almost impossible for potential predators to get a lethal bite. For those that are unable to retract into their shells, such as sea turtles, their best defense is speed. Turtle shells are capable of withstanding pressures up to 1,500 psi. Which is usually much higher than most of their predators' bite force. Some tests on turtle shells show that they can withstand almost 200 times a turtle's body weight, making it one of the strongest shells in the animal kingdom. Turtle shells defend against bite force, But in the deep ocean, the threat is not just teeth, it is immense pressure. The giant isopod is an underwater crustacean closely related to the pillbug. They are over 160 million years old and have adapted armor that is near impenetrable. Their exoskeleton is lined with overlapping segments that cover its entire body. The first segment is fused directly on its head, and the rear is fused separately to provide protection to its abdomen. The armor helps protect them in water so deep that it can reach pressures more than 1,000 times that at sea level, as well as predators like sharks and octopus, or other isopods who may turn to cannibalism when food gets scarce. Some animals reinforce their bodies, some are crazy enough to reinforce their teeth. The chitin is a strange looking animal. Using its shell for defense, they act similarly to isopods. However, their real strength comes in their teeth. Chitin teeth are incredibly strong and known to be one of the hardest biominerals in the world. These mollusks graze on calcified algae hardened on rocks. In order to scrape the algae, chitin have evolved to build their teeth out of a hard iron oxide mineral called magnetite, making them incredibly hard and resistant to wear. This also makes them metallic and are stronger than some forms of steel. Their teeth are arranged in 2 columns embedded into chitin fibers. They are layered in a way that when one falls out, as the next one grows, it is sharpened by the others in the column. The tip of the tooth, called the cusp, is where you will find the magnetite, also allowing the tooth to act as a grapple, holding onto rock where the chitin burrows and feeds. From chitin exoskeletons to bone-plated skin and iron-reinforced teeth, animal armor is not accidental. It is engineered, layered, interlocked, pressure-tested over millions of years. And the more we study it, the more evolution looks less like chance and more like a design. Thank you for watching.